Remember, we are calling them examples. 1, prove a cos x over sec x sin x, is it the same as cosec x minus sin x? Are the two the same? So where do we start from? So most of the identities, it's so clear where you're supposed to start from. So like in this case, it looks like, as we can all see, that we are supposed to start from the left-hand side. So let's see. Cos x over sec is the same as 1 over cos multiplied by sin x. This is the same as cos x over sin x over cos x. But this is just cos squared x over sin x. Is it?
Yes, it is.
How does it separate? I will say cos, depending on what I'm given this side, I need a minus. So from the most important identity, I know that sin squared x plus cos squared x is equal to 1. Hello?
Yeah, yes. How have you moved to cos squared x from cos over sin x over cos?
This is 1 in the denominator, is it?
Sorry?
It's like you have cos x over 1, or let me not even put the 1. So like we have cos x divided by sin x over cos x. Change division to multiplication, you have cos x multiplied by cos x over sin x.
Okay, all right. I judge.
Wonderful. So sin squared plus cos squared is 1. This means that cos squared is 1 minus sin squared. Everything is over sin x. But this is the same as 1 over sin minus sin squared over sin. But 1 over sin is cosec. And if we divide there, we remain with 1 sin on top. This is the right answer. Hence proved.
Akakali simple sa. Mave mwacho sapo.
Good. So what's the secret? Being able to change any trig that is not sine and cos, you change it to sine and cos. Another one. Another one, 1 over 1 minus sine squared y is equal to 1 plus tan squared y. Again, left hand side. From the most important identity, 1 is the same as sine squared y plus cos squared y over 1 minus sine squared is the same as cos squared. But this is the same as sine squared y over cos squared y plus cos squared y over cos squared y. But this is just tan squared y plus 1, which is our right hand side.
Sir, re-explain B.
So from the most important identity, 1 is the same as sine squared plus cos squared. So where there is 1, we replace sine squared plus cos squared. Then 1 minus sine squared y is simply, from the very identity, is simply cos squared y. So you substitute where there is that, you substitute cos squared y. Then you are able to split the numerator as long as you're carrying the whole denominator. Whether multiplication, division, anything. Another question. Another identity. C.
Oh, sorry, Sam. The previous board.
Okay. You were copying?
Yes.
Okay. See.
All right. All right, I'm done. Thank you.
Why have you divided cos squared y? I mean, it's already in the denominator. Or should the question be, where is it coming from? It's coming from this guy is just a piece of that most important identity. So today, before you have your lunch, you must make sure that you know the most important identity. Not just knowing that sine squared plus cos squared is equal to 1, knowing it to a point where even if you see cos squared, 1 minus cos squared, you must tell that this is sine squared. You must be quick to know that at this point, I need the most important identity. Let's see if we need it here. Proof. Now this one looks like you can start from either side, but we know sec and cosec only have cos.
Wait, sir, I have a question. On the previous one, it means we have to apply the most important identity.
Yes.
Okay.
That's where we are. Linda. Oh, you mean previous, this one? So
No, the other one. the one I meant. Yes.
We can move.
Yes, we can move.
Thank you. So tan squared minus cot squared is equal to, sec squared is 1 over cos squared. Cosec squared is 1 over sine squared. So let's start from the left-hand side. Tan squared is the same as sine squared over cos squared x. Cot squared is the same as cos squared x over sine squared x. Crucial here. Let's get the common denominator. How do we get it? It looks like these guys are going to blow up. Okay, let's see. Suppose we get the common denominator to be cos squared x sine squared x. The numerator becomes sine squared x cos, I don't know, another sine squared x minus cos squared x cos squared x. Yeah. Okay. So I should be case. It doesn't look so straight. Because if we split, then they will cancel. Nothing will work. Try to split that back, we'll be back. So you can't split.
So now imagine you are alone in the exam.
That's how you think. Whether alone or in public, that's how you think. Okay, so let's hold it a bit this side. Let's go to the other hand side. See if it will make sense faster than the other. Sec is 1 over cos squared. 1 over sine squared. Common denominator will be the same thing. We'll have cos squared sine squared. And then this side sine squared, this side cos squared. So you notice that even if we separate that one, still it won't give us what we want.
So let's
Maybe
try
they-
to say
Maybe they made the mistake.
Sir,
Hello.
what if we separate, then we change the denominator, we change into sine one side, and then the other side we change into cosine.
The denominator.
Yes, we separate at this point, then the denominator this side, this we have cos squared x, times sine squared x. We can change one of the two. And then even the other side, we can change one of the two.
So what if we separate them and then where there's sine squared x, we put 1 minus cos squared x. And the other side where there's cos squared x, we put 1 minus sine squared x.
That's your reason. We separate, and then we get ourselves to this. If we change
So at that point, I think we've proved since the sine squared x divided by 1 sine in there will remain with 1 over cos squared. Then even the other side, the cos and the will cancel and then remain with 1 over sine squared x.
it came from here. So if you get it back, you haven't proved anything. So let's get back to the first one, the left-hand side. Suppose we tempered with the numerators, one of them. So let's change one of these guys to cos. So you can have sine squared x, 1 minus cos squared x minus, we fix this. So get back to the denominator. I mean, yeah, let's just deal with the numerator. So if we expand, we have this minus sine squared x cos squared x. And then, okay, so this means that even here, let's change 1 minus sine squared x. So that when we expand, we'll have sine squared x minus sine squared x cos squared x minus cos squared x plus sine squared x cos squared x. So we notice that this piece and that piece will go. So now we can go back to the denominator so that we have this minus cos squared x over cos squared x sine squared x. We separate, we have sine squared x over cos squared x sine squared x minus cos squared x cos squared x sine squared x. So we see that from here, this guy and this guy, that guy and that guy, so we remain with 1 over cos squared x, 1 over sine squared x. 1 over cos squared x is sec squared x, and cosec squared x, our right hand side.
So you are just like trying to see if it's going to work. Now try to explain what's going on.
Oh, yeah. Okay, let's go back and explain. Now that it has worked. Look, since we have sine squared, cos squared, and we know that the multiplied identity allows us to move from sine to cos. So we change one of the sine squared here. So let's change the inner one, sine squared, you make it 1 minus cos squared. You do the same to one of these cos, you make it 1 minus sine squared. And then we expand. When we expand here, we'll have sine times 1 remain sine squared minus sine squared cos squared. This minus is there even as we have this inside. So when we expand, the first one remains minus, the second one will be minus times minus positive. So the positive and this positive, and this minus will cancel each other, then we remain with sine squared minus cos squared. We can now bring back the denominator. And when we separate, we have this minus this. So you notice that the sine, we have 1 on top, the cos, 1 on top, but this is what we had here, and these guys came from there. We know 1 over cos is sec, and when it's squared, sec must be squared too. 1 over sine is cosec, when it's squared, cosec must be squared too. And that is the right answer. So that now you go for physics. Have a good day.